Hi everyone, Aviad Cohen at AV Master. I have Mark Coxon today with me from XDG. Mark, how are you?
I'm doing awesome. Thanks for having me back. I enjoyed our first time doing this, and I was happy to get an invite to come back.
We're excited to have you here. This we had like two trade shows between interviews, and I think it's a great opportunity to look and reflect on what happened. But it's not. But you've seen like three major trends coming. The UC obviously is everywhere. Also seen digital signage, which brings me to our latest and greatest. LEDs are everywhere. Um, and one thing we noticed during the shows that some of them were dispersing a lot of heat. Now, and we spoke earlier on. He said this is not a must-have. This is not you don't. It's not something you have to endure. But I'd like to elaborate on it. So, what's the heating challenge of an LED technology? Where does it stem from? How could it be resolved? And then I
Yeah,
have another question.
no worries.
Uh,
So with LED, if you really understand what's happening with LED, you pretty much have, if you have a 1080p display, you have 2 million light bulbs on the front of a piece of black plastic. We'll boil it down that simple, right? Like we'll make it as simple as possible. 2 million light bulbs on the front of a piece of black plastic. And in most LED that you see out there, it's something called SMD is the technology. We don't have to get into exactly what that is, but for the most part, the wires that connect those light bulbs are right on the front of that plastic. And so any heat that's being dissipated is running through those wires because of a byproduct of heat, the inefficiency of electricity, you get a byproduct of heat, and that heat hits you in the face as you're walking by, this mega wall, right? So that's what most people are experiencing when they experience heat is just running 2 million light bulbs with these wires exposed. They do make some LED technology. So if you really wanted to start to get rid of heat or think about like how to dissipate it, they do make LED technology that is what they call flip chip. And for the most part, what it does is the wires are behind the light bulb instead of on the outside,
oh, okay.
right? And so when the wires are behind the light bulb, the heat actually goes backwards into the board. And so some of that heat isn't coming off the screen. It's actually going out the backside of the product. And so if it's going out the backside of the product, you can do something almost like they do in data centers. You can create air across the backside of the product to get rid of the heat, and you're not actually experiencing it as a user or as someone who's visiting the space. And then the other thing that's very interesting about LED is that there are different size light bulbs that you can put on the board. And larger light bulbs, typically you don't have to run them as you don't have to push as much electricity through them to get the same amount of light out. But what that does is it reduces the amount of pixel density that you can get. So if you use bigger bulbs, you can't get as much pixel density. If you use smaller bulbs, you can get more pixel density. What a lot of companies do is they just use the same size bulb for the most part, LED
Yeah.
package, because
Okay.
it's easy. But some companies like Nanolumens and other companies, they'll optimize the size of that light bulb for the pixel pitch and to get the best efficiency out of it. So it's just knowing a little bit more about the product itself. There are some technology differences you can use, and then there are some methods you can use once you have that, as long as you leave yourself some space between the wall and the LED on the backside. If you're using a product that dissipates more heat out the back, you can get rid of it that way. So it's not an unsurmountable challenge. It's just one of those things that you have to know a little bit more about the tech and why it's happening.
So if I were to summarize, it will be choosing the technology that has the wires running in the back. And as you said, like in a data center, you get the front, actually no, the front here and then the back here. And you just have to make sure the air vents suck up or disperse the heat from the back. And you said something about regulations about that's in the States. We're in Israel, so it might be similar. So you couldn't stick out of a wall too much. So profile wise in America would be 4 inches, which would be about 10 centimeters metric
Yep.
system and stuff. So what you said before is use as much as you can of that space to make sure you have enough room for the heat to run in the back and less heat comes in the front. So it's
Yeah.
a more enjoyable sensation for whoever crosses path with that screen. You're also stating that there are different, again, this is layman's terms, but different bulb size that you could use on the same board. So if you have like a 3.5 pixel pitch or a 3.9, if you use bigger bulbs and not go with the same stuff that you have, you could place less bulbs, get less space on the same surface, get a bigger image, or actually get a good image, and spend less energy and less heat on generating, on getting the same brightness than as you would like in a 1.2 pixel pitch bulb. Am I correct?
Yeah, there's definitely, so when we were talking about the envelope there, you're talking about in the United States, we have ADA, the Americans with Disability Act, and that act has a regulation that that you can't have a display that stands more than 4 inches off the wall, because it becomes a clipping hazard. Maybe if someone was blind, was walking by and they had a cane, the cane would go underneath it, it's sticking out off the wall, and they would still hit it or run into it, which isn't great. Which isn't great for the person or the technology, honestly, either or. So I think the temptation is a lot of times when we're using things like LED cabinets, which are very, very thin, they're within a couple inches, of depth, that a lot of times integration here in the United States, the temptation is to move that as close to the wall as possible and create the smallest profile, even under that 4 inches. Whereas I'm saying, if you can use the 4 inches, keep it at the 4-inch envelope and keep those extra 1.5 to 2 inches behind it in order to create a chimney, right? Some type of chimney effect that you could push an air curtain through. So there's this temptation that you might want to avoid if you don't want all the heat to have to come towards the front of the screen, for sure. And yeah, when you're talking about the bulb size, it's interesting because from a manufacturing perspective, if I was putting light bulbs on plastic, and that's what I'm doing in an LED factory, if I put 2 million on this one and I put 1 million on this one, I would just, from an inventory standpoint, from a manufacturing standpoint, it would make sense to just have all the same size light bulbs and just put less on one board in a 3.5 than I put on the board in a 1.5. I got to put more, right? But that may not be the best way to actually create efficiency on that other screen, right? There may be better to put larger light bulbs on the one that's 3.5 because you have the space between. And if you think about it, if I have 2 small dots, 3.5 millimeters apart, I'm seeing more of the black plastic. But if I have 2 larger dots, the same 3.5 millimeters apart, I'm seeing less of the black plastic and more of the image. So from a visual standpoint, the user actually gets kind of a cleaner image than if they were using those smaller packages where they're not really needed, and you don't have to run them as hot, right? So just little teeny tiny things that if you understand the technology a little bit, you can go out there and start to ask manufacturers questions that they're probably not normally asked. Like, are you using SMD? Are you using chip on board? Are you using flip chip technology that has the wires on the back? What size of light package are you using on your 1.5 versus your 3.5? Those are questions that are readily available as far as answers go from your manufacturing partner, and they can help you really get that heat down and improve the image quality really too, which is another advantage of it.
I think, there's like it's like a crossing of a few categories to get one good product. It's like one good solution would be. Mark, you have a lot of experience, obviously, in this industry. A question to you, from your experience, how much the heating issue could affect users or systems integrators or whoever on choosing the right technology? The right LED technology for them.
What, as far as just like best advice in choosing a partner?
No, what I'm trying to understand is how much is the heat problem, if you're not very much aware, how much would it affect you or affect your choice of an LED?
I think it depends on the environment. I mean, as integrators, I would say as integrators, we've faced this kind of in another way in rack rooms for a long time, right? When we create an AV equipment rack, we're always working with our other partners to dissipate the heat that comes from those racks. So like from an AV integrator's perspective, I'm working on a team of people, one which may be an MEP firm, which is the mechanical firm that's doing the HVAC, or the engineering firm that's doing our air conditioning systems and spaces. And they're asking me for total heat loads out of the rack, and I'm providing those as part of my deliverables through the construction drawing set of this is how much heat my equipment dissipates within the space, this is how much power it draws, and they plan the circuits and they plan the air conditioning throughput, right? And I think in LED, I think it's the same thing. It's just we have to understand what those implications are so that we can give that data to our partners, and they can make sure that they're mitigating the heat and the power draw from those, like they would in a rack room or somewhere else. So I think on the screen side, other than power draw, we have had to deal with power draw for a long time. Like if we need dedicated circuits, or, hey, I need 12 dedicated 15 amp circuits. You can't give me one 15 amp circuit and 12 outlets. I need each outlet to be on a dedicated 15 amp circuit for this piece, right? So we've done that before from the power side. I think because it wasn't as much screen side heat in LCD, we didn't really, even though the product always produced heat, maybe we weren't as aware of it as we were before.
Right.
In this case, I think we just have to make sure to let them know that these pieces of equipment do generate screen side heat, and to make sure that we're mitigating it in that way. So, I mean, I always like to use more efficient product. There's a whole, at InfoComm this year, Christina DeBono came out with a whole initiative called SAVE, which is sustainable AV, and making sure that you're thinking more about sustainability and green practices in creating AV systems, not only for e-waste, but for things like efficiency. We've seen Energy Star on appliances and stuff for a long time. And AV, I don't think we've ever really seen that as our job. Somebody else may tell us that they want us to use certain things to get LEED certification or some of these things that we have for sustainability. But I think it's just something we have to think about more. It has to be more in the front of our mindset than maybe it was in the past, because it is something that a user experiences when they view the screen.
I see. Kind of makes sense, to have a reliable, informed, knowledgeable partner to tell you, as a customer, in layman's terms, this thing is going to produce this and that heat when placed in that environment. You would need to take these actions in order to get a good image of what it is that you want, but not get all the heat. It can be done through these products, these flip chips and whatnot, in order. So what I think, staying informed and knowledgeable will reduce the number of overheating or unpleasant LED solutions. I think that could help out adoption in the long run. And from what we've seen in this year, LED is not a matter of time. It's just a matter of when. It's happening.
LED is totally happening. I mean, you've seen LED even start to go into some prototype movie theaters where nobody ever thought LED would be a player, and we've started to see some of that, which is very interesting. You're seeing very high resolution, low pixel pitch displays, under 0.7 now on the market. And if you think of like an 80-inch LCD display, the pixel pitch is, if you had to do a pixel pitch on it, it's about 0.55. If you did that, so 0.65, 0.66 is getting real close to what the pixel pitch is on an LCD screen, on a 1080p LCD screen at 86 inches. And so pixel density is getting better and better and better. And installation is getting somewhat easier. And the damage, the damage mitigation, when I talked about something like chip on board or glue on board, those products are coated with an epoxy or some type of glass encasement, which really makes the installation a lot easier. You have a lot less damage, and you have ways to actually wipe the product down for dust and things like that without having to do compressed air or special tools or any of those things. Whereas, in the past, if you took a rag and wiped it across the front of an LED screen, you're gonna create a swath, a canyon of pixels that fall off of the screen when you do that. Now there are a lot of products you can go spray and wipe down.
I think we've seen one, and one of the larger manufacturers at IC said they have a special coating just for that, so you can have a clear image.
Yep.
Wipe it off, stays the same.
Yep.
Cool.
Yeah. It's coming a long way, and those coatings also allow you to use them for interactive screens. I saw a lot of touch LED on the floor this year at Infocom, which is interesting. LED was something you were never supposed to touch without a white glove, and you only touch it when you install it, and please don't ever touch it again. And now they're doing LED screens that are touch screens. You put a bezel around them, or LiDAR, or some type of IR bezel around it, just like you would. So it's not a piece of glass. It's not a piece of capacitive glass over the top that's protecting it. You're touching the actual
Pixel
LED pixel itself that's encased in either an epoxy or some type of glass resin. And you can use it as a touchscreen and wipe it down when you're done. So I think we're seeing a lot of advances in that technology, and places where you said LED would never work, all of a sudden LED works, right? So
great. So Mark Coxon, what it is you're telling us is LED is the future. You know, go boldly and go bravely into the future. It is LED. Do not worry about the heat. Consult an expert, and you'll be just fine. I'd like to thank you very much for your time. It has been a pleasure. Looking forward to our next meeting, and see you then.
All right. Well, hey, thank you so much. I appreciate it.
Appreciate it. Have a great one.